University of Oklahoma. Today we're going to have a guest speaker, Gregory Wrightstone. He is actually a geologist from the University of West Virginia, gone around the country and spoken to all sorts of industry groups, civic groups, etc., bringing a different viewpoint or just a geological viewpoint with regard to how dangerous is global warming. Should it be something we're concerned about? Should it be something we address? Gregory, I'll let you go ahead with your lecture, and when we have like an hour and 15 minutes, and I'll open up for questions if you want. And you did this last year for me, and it went over very well. We are recording it. There's about 10 students, and about 5 students haven't made the class. You haven't seen it. If I switch the camera around, there's probably 55 students in the seat. So this is a big class. So I'll let you go ahead and proceed.
Yeah, thanks for having me on. I speak to a lot of scientific group and other groups. I just spoke to the Ohio Geological Society last week in Columbus, Ohio, to about a group of about 45 geoscientists. What we're going to do here, I'm going to talk about climate change, the facts, and then some. So we're going to focus the first half of this talk on the basics of climate change. We'll go through carbon dioxide, the greenhouse gas, temperature, some facts you may know, and a lot that you won't. We've heard a lot of the 97% consensus. We're going to go into that in a little bit of detail later on. But I will tell you there is a consensus among most scientists on the following. First, CO2 has been increasing, and most of that CO2 increase is due to man's burning of fossil fuels. Also, temperature has risen about 1.5 degrees Fahrenheit over the last 100 or 150 years. Most scientists also agree that increase in CO2 is driving some warming of the atmosphere. The disagreement becomes on how much of that is. People like on the Intergovernmental Panel on Climate Change, which is the IPCC, Al Gore and Dr. Michael Mann, pro-man-made catastrophic warming side, will say that this increase in temperature is driven primarily by man's increases of greenhouse gases, and that those increases in temperatures driven by CO2 and others will lead to catastrophic consequences. The other side of the debate, and yes, Virginia, there is a debate, although they don't want it to be recognized, is that people like me, climate skeptics, agree that CO2 increases will warm the atmosphere to some degree. I will argue it's fairly modest, and it's being driven primarily, the temperature increases we see are driven primarily by the same natural forces that have driven temperature really since the dawn of time. And also, I'll argue, from my standpoint, very strongly, that rising temperatures and increasing CO2 are having an overwhelmingly beneficial effect on the Earth and humanity. One of the first inconvenient facts we look at is that carbon dioxide is not the primary greenhouse gas. If you go to the National Geographic website on greenhouse gases, this is what you'll find. They list carbon dioxide and some other gases. Nowhere, and this is from the EPA website, very similar to what the National Geographic has to say. Neither of these sites provide information on what the real primary greenhouse gas is. And that's water vapor. Water vapor is thought to take up 75 to 95% of the greenhouse warming effect of all the greenhouse gases. The carbon dioxide, if you ignore water vapor, what that tends to do is overemphasize the role that carbon dioxide plays in greenhouse warming effects on the Earth. I think it's by design, perhaps, because everybody on both sides agree that water vapor is the dominant driver. But yet it's ignored for the most part. The second fact we looked at here is that the warming effect of each molecule of carbon dioxide decreases exponentially as the CO2 concentration increases. In other words, that first 100 or 200 parts per million of CO2 provide the bulk of the warming effect that you get. And as CO2 is increased, each additional molecule of CO2 has less warming effect. And that's important because, as we'll see going through here, carbon dioxide through time has been at 10 and 15 times the levels they are today. And that's why we didn't have any runaway warming when CO2 levels were exceptionally higher than what they are today. And that's why we won't have runaway warming when CO2 levels continue to increase, which they're going to. So the gases in the atmosphere, primarily nitrogen and oxygen. The trace gases are listed on the right. And you can see that CO2 really is a trace gas of the trace gases at 0.04%. Although it's a very small number and a very small percentage of the atmosphere, it's a really important molecule. We call it the miracle molecule of carbon dioxide. Life as we know it would not survive. And it also does provide some warming effect to the atmosphere. And the sources of human emissions of CO2 are listed here. It's primarily fossil fuels. You may not know that about 5% of CO2 emissions are from the manufacture of cement and a little bit from gas flaring. And again, we see that natural gas, of the three fossil fuels, natural gas provides the smallest number of pounds per CO2 per million BTUs. Of course, coal provides much more CO2 in terms of per million BTUs generated. And again, the countries, who are the countries that are emitting the most CO2? It's China. India is increasing their role here. The U.S. is number 2. We can talk more about India in the Q&A section because they're backing away from their renewables and doubling down on coal-fired, opening up 20 new lignite and coal mines they've just announced. And they've actually just reached 100% electrification of the country. There were some recent reports about how carbon dioxide had reached record highs, and it was higher than it's ever been in history. We haven't been this much CO2 for 4 million years. There's a kernel of truth in that. What we're going to do is take a look at this in the longer term and see what our current increases in CO2 actually look like in the long-term geologic look at this. Here are CO2 emissions, human CO2 emissions, dating back to the year 1759. You can see that there really wasn't much CO2 emitted by us. It was that post-World War II boom in the mid-40s, the mid-20th century. And I want you to concentrate as we go through, in the blue highlighted area to the right is that 1945 plus era in the 20th century. If we're going to see CO2 driven temperature increases, this is the period of time where we're going to see it. As we go through these charts, blue is always going to be carbon dioxide. If you see blue, it's CO2. And any temperature that I show you will be in red. And then future and present is to the right, going back into time to the left, as we go through charts. I want you to also notice every chart that I'm going to show you is fully sourced and referenced. It's really important in this debate that we, number one, get it right, get the data right, and then also, where did that data come from? It's important to note that. So you'll note there at the bottom, and I'll be providing a copy of this presentation to the good doctor here after we're done. So again, we look at the last 100,000 years of CO2 data. This is from Antarctic ice core data. We see that before the Industrial Revolution, we were running about 280 parts per million of CO2. We're currently a little over 400 parts per million. You're only going to need to require, I'm going to ask you to remember a couple of numbers. 400 parts per million is one of those, and that's where we are today, a little bit over that. You'll see also I've got a red circle down to the right, dangerously low CO2 levels. We'll get into that in a minute. But is this increase from 280 to 400? It's about a 40% increase in CO2. We're told that this increase in CO2 is not only dangerous, but it's harmful. So let's look at this. We really need to put this in a bit longer perspective. And here we see 400,000 years of CO2 data, again from ice cores, and they're able to access the bubbles captured within the ice to get this data. And during each warming period, the blue shaded areas are the ice ages, tan colored are the interglacial warming period like we're in right now. And I think this is a good chart to show that our 400 part per million that we're at right now is unusual. It's not, we go through the other interglacial warming periods, we saw they were around 280 to 300 parts per million. So this 400 is unusual. At this point, let's take a look at and discuss why does CO2 level fall during the ice ages? And that's because the ocean is the primary driver and receptacle for carbon dioxide. It's the largest CO2 sink. As water cools, it absorbs more carbon dioxide. A warming ocean expels it. And if you could imagine taking a liter jar of ginger ale, putting it in your refrigerator, open it up, it just goes. You put it out in August on your patio table and open it up, and it's like a volcano going off because that's the CO2 in that liter jar of ginger ale being expelled. We see the same thing with the oceans during the ice ages. And looking closely at the record, we find that during each one of these ice ages, temperature changes and then CO2 changes. In other words, the oceans start cooling and they start absorbing or sequestering more CO2 in the water. And as the warming starts and then the oceans start expelling CO2. So it's different from what we're being told. We're being told that CO2 is driving temperatures, where we know historically that's just the opposite has occurred. But again, the IPCC and others will tell you, well, everything has changed because we've added all this additional CO2. So let's take a look at this in a little bit longer term. And we'll find out that actually our current geologic period has the lowest average CO2 levels in the history of the Earth. We're going to look, this here shows 600 parts per million, or 600 million years of data. A couple things you want to look at there. The blue hatched line at the bottom is our current level of CO2 at a little over 400. The red dashed line we'll come back to. That's what I call the line of death. The reason for that is that that's 150 parts per million. It's the level below which plant life can't survive. It's the minimum threshold for plants. Most plants need at least 150 parts per million. You can see also, looking back to the Precambrian and the Cambrian, the Earth has been generally in a long-term decrease of carbon dioxide. Life has flourished during other periods with much, much higher levels of carbon dioxide. And again, just looking at average for each of the periods, we see that, again, our current levels are very low. And probably the most scary chart that I have in my book and that we'll look at today is this one. It's the dangerous 140 million year decline of decreasing CO2. Nearly a straight line, linear decline of CO2 going from 2,500 parts per million down to, at the end of the last ice age, we got to 172 parts per million, the lowest level of carbon dioxide since the Precambrian. That's a scary, scary notion. We got within 20 parts per million, 22 parts per million of crossing that line of death. If we would ever cross that, that would be a true climate apocalypse, because without plants, I don't need to tell you what the rest of us would be doing. We wouldn't be. So this is really a scary chart. And what this serves to show is that rather having too much CO2, we don't have enough. We're actually CO2 impoverished, looking at all of Earth's history. Now, we've added, again, I would say thankfully, we're adding CO2. And we'll take a look at some of the benefits later on of increasing CO2. One of those is the stimulation of plant growth. The CO2 fertilization effect means that plants use CO2 as a building block for both like the crops that we eat, the trees, all plant life. And you can see what an increase in CO2 is shown here by Dr. Craig Idso. His team did laboratory tests in this chart by increasing the CO2 in laboratory greenhouse experiments. They increased it by 300 parts per million. And the green numbers on the right are shown what the percentage increase in crop growth, biomass of each crop is shown here for each one of these types of foods. This represents 95% of all crops grown on Earth. And we see that an increase of 300 parts per million will lead to a 46% increase in biomass of these crops. That's a good thing. That's a really good thing. We'll be able to feed people, feed more people, and we're seeing that. We'll look at this a little bit more detail later. So why do we get this? Now, when you all were little lads and lassies back in middle school, you studied the process of photosynthesis. But I'll remind you what's going on here is that plants use carbon dioxide. It's brought in through the stomata or pores in the plants. It's combined with water that's sucked out of the soil through the root system, combined with sunlight, produces a combination of glucose and oxygen. And it's the glucose that's really the building blocks of the plants. We're going to get in now into the temperature section here. We're going to look at, first, we'll take a look at the Dr. Michael Mann out of Penn State and his hockey stick and why it's so important to this debate. Before Michael Mann came out with his hockey stick in the late 90s, this is most climatologists agreed with this. This is a recreation by Dr. Hubert Lamb, he's probably the preeminent, the father of modern climatology. Looking back over the last 1,000 or so years, pretty much everyone agreed with this. This is based on historical records and some proxy data that were used. But the key thing here that we'll talk about time and again is 1,800 years ago, 1200s to 1400 was the medieval warm period, a warm period much warmer than we are today, followed up by the Little Ice Age, which was a horrifically cold period, and then a slight warming, but I would say a thankful warming coming out of the Little Ice Age. It's been called the long, slow thaw coming out of the Little Ice Age. In 1998 and 99, Dr. Michael Mann from Penn State published two seminal works that have been referenced. This is what's known as the hockey stick. The blue line this is temperature over the last 1,000 years, showing a gradual declining temperature. That's the shaft or the shaft of the stick, the handle of the stick, and the red in the beginning of the 20th century is the hockey stick's blade there. That's why it's called the hockey stick. So what he did was use proxy data, mainly tree ring data from the trees called the bristlecone pine, to come up with this as a proxy for temperature. The authors of that study warned specifically not to use their data on these bristlecone pines for temperature proxies, because they said that according to them, there were multiple reasons why tree rings can grow, and those tree rings, including temperature just being one, also included was precipitation and increasing carbon dioxide. So what he says, according to Dr. Michael Mann, this is picked up by the IPCC, was that a long, slow decline in temperature and then a sudden increase in temperature in the beginning of the 20th century that coincides with increases in CO2. It's important for them to convince you and the public that the warming we see today is unusual and unprecedented. And these are the two words that are used are unusual and unprecedented. And as we go through this today and we look at more data, I want you to be thinking about that. If our temperatures in the late 20th century and 20th century, early 21st century, if they are indeed unusual and unprecedented, that would be a strong case for CO2-driven warming, CO2 being the primary driver. And as we go through this today, we're going to be putting this data in a much longer context to look at it. And so as we go through here, I'd like to build a case on whether or not, I'll let you make up your own mind. I won't tell you. We'll look at the data, decide for yourself. Are our temperatures today unusual? Are they unprecedented? One of the things they talked about is that our temperatures, recent temperatures, are the warmest in history, warmest ever recorded. And actually, in many cases, they're correct. I'm not going to dispute that. But the key here is, what is that temperature record? What is the history they're dating to? Most of when they talk about this goes back to only 1850. Much of the NOAA data starts there. Much of the temperature thermometer data starts there. The first satellites, it's important to know, for measuring temperature and climate related issues went up in 1979. So we've got 30 plus years of data from satellites. Is that long enough to use? It's probably the most accurate measurement tool, but we're limited with the amount of time that we've had access to it. This is an important temperature chart, combinations worldwide global temperature of surface, and that's land and sea-based, showing a general increase, again, going back to 1850. This is a chart that's used a lot, and if we combine carbon dioxide emissions to this chart, I think everyone in the room there probably nodding their head and agreeing that, yeah, boy, that looks like a pretty good correlation. Boy, we start increasing CO2 and CO2 goes up. But I'll emphasize to you, correlation is not causation. So let's take a look at this in a little bit more detail. You'll remember we looked at the CO2 emissions data and said that it started in that post-World War II economic boom. So let's take a look at this temperature data set from that 1944 era to the most recent data we have. And we'll see that 70% of the time since the mid-20th century, we've either been in a cooling temperature or a stable temperature. And I would argue that if temperature was being driven by carbon dioxide, that should be reversed. We should see at least 70% of the time that temperature is going up, not cooling. And the first indication we got of that was, again, in that period from 1944 till the late 70s. We went through, just as CO2 emissions really started ramping up in earnest, we went through a 33-year cooling effect on temperatures. This was the period of time I graduated, got my bachelor's degree in 1977. During that time, there were pretty horrific winters that ended that period. There was a lot of talk at that time about possibly going into the next ice age or another little ice age, because we'd gone through 33 years of general cooling of that. And the other inconvenient fact here is what I call the inconvenient pause, where we saw about 18 years of fairly stable temperatures. And in fact, the IPCC admitted, this was in their 2012 report, that there was no statistically significant warming during this period. So what's happened since that 2014 date? Well, in 2015 and 2016, we had a pretty good bump in temperature, big increase in temperature. Most neutral observers point this as a relationship resulting in a giant El Nino effect in the Pacific Ocean. NOAA called it the largest one they've ever measured that caused that bump in 2015 and 16. Temperatures have fallen more than half a degree centigrade since then, back to the level of what it was during that inconvenient pause. So again, this is surface data that we're looking at here. Now, we'd looked at this chart before. Remember I said that this was looks like a pretty good correlation, but let's put this into the longer perspective. This is the Central England temperature record. It's the longest thermometer-based temperature record available. It's not shown much, and for good reason. It starts in the year 1659, and the key thing here, the takeaway is our warming started in the late 17th century. In fact, we know what year it was. It was the year 1695. It was the depths of the Little Ice Age, a time called the Maunder Minimum, and it was horrifically cold. During this period, the River Thames froze over on a yearly basis. The last time that happened was 1812. We've been starting this warming, and in this warming period for 300 plus years now. The first 200 years of this warming had to have been entirely naturally driven. And the first 200 years look a lot like the last 100 years when we started adding CO2. So this is probably one of the more impactful slides that we'll look at here in the relationship between carbon dioxide and temperature increase. And again, that other slide, I want to reinforce that correlation does not imply causation. And there are a couple other things we can look at with pretty good records that relate historical records that we can measure with the temperature. We'll take a look at sea level a little bit later, but this is a compilation here of glacial retreat that was measured I believe there were 150 some glaciers that were measured throughout the Earth, mostly North America, but not all. And we see here that the glacier shortening began in the early 1800s. And then by 1850, the rate of glacial shortening stayed about the same until now. And again, we have very accurate records because during the Little Ice Age, glaciers descended across Europe, wiping out and advancing on villages, farms. It's thought that a third of all of the region of Chamonix in France was lost due to snow and ice. So these glaciers, these were very important and accurately measured where the tongue of the glacier was, and they've continued doing that. And of course, there's a strong correlation between glacial retreat and sea level rise. And we can see here, these are using tide gauge data, which is the best long-term measuring available for measuring sea level. Again, remember that the satellites that you can use to measure those only began in 1979. So for long-term data, you have to use these. And again, this is accurate measurements. And again, we see, just as we saw with that glacial retreat, we see that the sea level rise coincides with that. And by the mid 1800s, the sea level rise was at about the same rate as it is today. Bear in mind that sea level difference, rise and fall, are driven only by land-based glaciers. That would be Antarctica, Greenland primarily, but a lot of this drive came from the northern hemisphere retreat of glaciers and the melting of ice on Greenland. Just curiously, you might not realize it, we could melt the entire northern polar ice cap and it would scarcely affect sea level. And that's the reason, because that's ice that's floating on water. So the bulk of that ice is submerged, and that ice volume is then displaced as the ice is melting. Just so think about the Titanic and the iceberg that sank it. Most of it was submerged. And if we take a look here at compilation of proxy records there were 18 peer-reviewed studies, great study. The author here was Craig Lowley, who did this. One of the things that was curious was that he said that he elected not to use tree rings because he didn't trust the data very well because of them being influenced. We can use a number of different other kinds of proxies to measure temperature. And this is a chart that closely resembles that one we saw of Hugo Lamb's going back that we saw originally before we looked at the hockey stick. So again, we see the medieval warm period, Little Ice Age, and that our current temperatures are not as warm as the medieval warm period. A little bit longer data, 800,000 years. Again, we see rise and fall of temperatures on a 100,000 year cycle. Current interglacial warming period we're in right now is not nearly as warm as the last one. And there's been somewhat of a steady decline of these interglacial periods leading up to the one we're in now. Again, this is an impactful slide. When we talked about unusual and unprecedented warming, this slide ranks in the top 5 of the ones you're going to see today. This is 10,000 years of temperature data going back to the end of the last ice age on the left. And you'll see that our current period that we're in right now, there were 9 other warming periods similar to the one we're in right now. All 9 of those had much higher temperatures than we are today. You'll see that the Little Ice Age, actually, the recent Little Ice Age, has some of the coldest temperatures over the last 6,000 or 8,000 years. In addition, I've taken a look at the rate of warming for each one of those previous warming periods, and 5 of the 9 warm periods had higher rates of warming than we've seen in the 20th century. Again, is it unusual? Is our current warming unusual? Is it unprecedented? And then taking a look at the temperature in a little bit longer perspective, we look at 3.5 million years. The takeaway here is we've been in a general decline in temperature. And if we look going back another 65 million years, we see that much more vivid example of the cooling that we've seen long term. For much of this time, we find that Earth is either in a really warm period, which are known as hothouse conditions, or really cold periods like we're in right now, which are known as icehouse conditions. So again, the big takeaway here is we've got some of the lowest temperatures we've seen, even in this warm period, interglacial warm period, than what the Earth has historically had. Again, this is a chart showing 4 billion plus years of temperature data. Again, showing the ice house and the hothouse conditions, showing that our current temperature state that we're in right now is actually unusual in that it's unusually cold. One of the favorite things a lot of people, when I talk to them, and one of the things I like to talk about are the relationship, the strong correlation between the rise and fall of temperature and the rise and fall of civilizations. We see that in the past warm periods, during the Minoan, the Roman, the medieval warm period, great civilizations rose up, empires flourished, people prospered. During these warm period, historically, great crops could be grown, food was bountiful. You didn't have to worry about feeding your family next week or next year. You know, and so if you were Emperor Dancy in a warm period, you didn't have to worry about feeding your subjects because there was plenty of food to go around. If you were Emperor Dancy during a cold period, though, that was a different story, because what we saw consistently between each warm period and as we entered the cool periods, we had a significant decline in food productivity. We had famine, pestilence, and mass depopulation. It's thought that during the Little Ice Age, half the population of Iceland perished. It's thought that a third of the population on our Earth perished during the Little Ice Age. So things go bad in cold, and that's just opposite of what we're being told. Fascinating relationship we'll get into here. I've got a YouTube, Inconvenient Facts YouTube page where I've got a YouTube on this that actually opens up with a Monty Python skit with them bringing a witch up to her. But this is a relationship between climate and temperature and witch hunts in Europe. This is kind of I was going to say fun. It wasn't fun if you were thought to be a witch in the Middle Ages, but there's a strong correlation between when these witch hunts occurred and the temperature. Because as the temperature started dropping as we went into the Little Ice Age, crops began to fail. The people suspected that they were weather-causing witches. In fact, the Pope at the time issued an encyclical stating that there were such a thing as weather-causing witches and pretty much giving the okay to go kill them. So they had at it. And the number of witches we'll look at here in a little bit. It was funny though that, again, not funny if you're a witch. Around 1500, it started warming up again. Crops came back. Food was finally plentiful again. Well, why was that? They killed all the witches, right? That's what they said. Oh, good. That only lasted for 40 years, and then it really started getting cold. That's when the really, really big witch hunts. Most witches were burned at the stake or some drowned. Here's a chart, again, comparing the witch hunts in Europe in the late Middle Ages with the extreme temperature cold. The takeaway here is, while it's an interesting story, what it does serve to do is document the horrible consequences cold rather than heat. And we're being told that heat and increasing temperature will lead to crop failure and death, when his history tells us just the opposite. We'll take a look at the 97% consensus, which was John Cook did that. In his 97% consensus, these three were all descriptions of what people believed. Because I believe that CO2 is increasing and the increasing CO2 is warming the atmosphere to some degree, he would include me in that 97% consensus, which is, so he cast a wide net to capture all that. The bottom line here, great quote from Michael Crichton, but science is not consensus and consensus is not science. We're being told that there is a consensus and that there is no debate because the science is settled. That's not how science works, and that's not how it should work. For the remaining time here, we'll take a look at what I call the climate apocalypse events. But first, we'll take a look at John Christie's chart of climate models versus actual temperatures measured. According to him, the climate models used by the IPCC over-predict warming by 2.5 times too much, 3 times too much in the tropics. So what we see here, we've got these, as we go through here, it's important for us to separate speculation of what may occur 30, 50 or 80 years in the future that are based on failed climate models and what's actually happening. So we'll take a look at what's actually happening in the real world. So that's what I look at. I look at, so what's actually happening, separating speculation from actual data. I'm going to devote a lot of this time that's left to forest fires because I think it's so important. Forest fires are what really got me hooked in. Whenever I found out the actual truth, I was sucked in because I didn't set out to write a book. I set out to seek the truth. I knew that some of the things we're being told about climate change were just wrong. And it was this search for the truth that led into the book and to what we're going to look at today. And it was forest fires is when I had this epiphany. I said, oh my God, we're being told X and it's really Y. So let's take a look at it. Everybody, because I thought forest fires were increasing. Like most of you probably listening today think that forest fires are increasing. Well, let's see what the science tells us. In the last national climate assessment issued in November, the forest fires and wildfires were highlighted as the event. This is the front cover of their summary. The back cover also had pictures of fire. And they stated flatly that forest fires had been increasing and that they were predicted to increase in the future. So what does I get a little bit worked up. I get angry about this when I see this. And let's see what's actually going on. This is from their report here, increased wildfire activity. The only chart they had in the National Climate Assessment was this chart, acres burned in the U.S. from 1985 to present, okay? No source, no reference. And I looked at that and I said, whoa, man, I looked and looked and I found out what it came from. It was this chart. This is the acres burned from the National Interagency Fire Service and the U.S. Census Bureau that used to capture the data. We see that the current acreage burned is 20% of what it was 80 years ago. They cherry picked 30 years of data and used that. Yes, the area burned has increased slightly over the last several decades. We'll talk a little bit about that. That's not a global warming issue. That's a forest management issue. And so what we see actually, it was an outrageous abuse of the scientific process. I was the first to recognize this. And it was, again, it's an abuse of the scientific process, what they've done here to promote their agenda. We also see from the NIFC, this is number of fires, again, a significant decline. And you'll see that recently over the last several decades, there's been a slight decline, certainly no increase in fires. And if we look at area burned across the Northern Hemisphere, we'll see that there's been a long-term decline dating back to the beginning of the 20th century. And again, this is from Yang and his team. Our results suggest a notable declining rate of burned area globally. This was an important paper that was published by Flanagan and his cohorts at the Canadian Fire Service. They didn't have any cool charts for me to show you, but I think it's important to read what they had to say. That they believe that global warming since 1850 triggered decreases in fire frequency, and they go on to state that it will lead to further decreases in fire frequency. That's right, global warming is causing decreases in fire. And we see that from these aren't the only experts stating the same thing. We'll look at why rising temperatures and increasing carbon dioxide are leading to decreases in fires, drought, and intense heat waves. California was inflamed this year. I did a lot of interviews about that. What's fascinating is CAL FIRE is the data source for all things fire in California. This is their data showing that forest fires have declined by almost 50% over the last 30 or so years. The number of fires in California, if we look at the area burned has increased somewhat significantly. So what that tells us is each fire that's ignited ends up being twice or more as large area as what they were previously. And they're probably more intense. This is not a global warming issue. This is a forest management issue that we have here. Again, we see decreases over the last 30 or so year in fire frequency. So with wildfires, we need three things. We need an ignition source, we need fuel, and we need arid conditions. And what we are doing are exacerbating each one of those things, making it worse and increasing fires. The ignition sources are primarily somewhere around 80 or 90% of all wildfires are ignited by man, most of them accidental. The majority are electrical in nature. This is Paradise, California before the fire. There's thought to be 1,000% increase in people living in fire-prone areas in the West. So we have, just think about all those new ignition sources and people out there. It's a miracle that we did see a decrease in fires. Interesting graph here. The blue are lightning, natural ignited fires. The red are human ignited fires. There's been a lot of talk that the fire season now is extended throughout the entire year. And that may well be the case in some years, but that's because there's so many people providing ignition sources. Really, the only lightning strikes that cause fire in the 3 summer months for the most part. And that's because it's so dry. Because a lightning strike is just a burst of energy and then it's gone. Where most human-sourced ignition sources might spark and spark and spark and spark and lead. They last long enough to create a fire. And again, we talked about forest management. This is the Sierra Nevada Conservancy says that there are now 4 to 5 times too many trees per acre. And think about that. What that means is that there are more. We know that leads to more fuel for the fires. But think about it too. The second most impactful source of aridity of the soil or moisture loss is the water that's sucked out of the ground by the plants and the trees. So now we've got 4 to 5 times as many trees competing for that same scarce soil moisture. So it's causing arid conditions and soil moisture to be lessened. And why are forest fires declining? It's a combination of rising temperatures and increasing CO2. Rising temperatures means that more water vapor can be incorporated in the atmosphere, which leads to increases in precipitation. Some will say, and it's definitely been said, anytime there's a flood, that increasing precipitation due to rising temperatures will cause flooding. And in some cases it might. But what we'll see here is the big story is that it's leading to soil moisture increase and a greening of the earth. And that's really turbocharged with increases in CO2 fertilization, which means that plants need less water. Their stomata are smaller. They're not transpiring, breathing in and out, and losing all that water. So the water stays in the ground. Both those things are leading to a greening of the earth. The green here represents vegetation increase. According to NASA, up to 50% of the earth is greening or increasing vegetation. Less than 4% of the earth is what they call browning or desertification. So if you're going, I've never heard that, you can go ahead and Google NASA and greening and see what you find. And what you'll find is astounding. It's remarkable what we've seen. New recent study shows in more impactful detail the greening of the earth, especially in India and China. We see it in Australia. We see the same thing. Again, the green here represents increases in vegetation. The yellow or brown are areas of decrease. That's a good thing. That's huge, leading to crop growth, plant growth. Probably the most stark example of this greening is an area called the Sahel. It's in the southern Sahara, and it's an area 300,000 square kilometers of former desert are turning into a lush grassland. There are animals are moving back into this area. Gazelles, even amphibians are moving into this area. People are moving back into the area that haven't lived there for 1,000 years or more. There's crops being grown in former desert areas due to climate change. We see that increasing temperatures means that tundra is receding, tree line is advancing. Dr. Tim Ball in Canada says that the tree line in Canada over a 200-year period has advanced 200 kilometers over 200 years. We see that there are predictions of drought. This is the EPA's index on drought versus drought severity index. Definitely not an increase in drought severity. Again, this is the percentage of the U.S. that are either very wet or very dry. We've been very stable since the beginning of the 20th century. And then we see worldwide drought is in a slight decline over the last 30 years. And this is an interesting study that was done. They took a look at the most severe droughts of the 20th century. These are the big ones, the Sahel drought in Africa, the Dust Bowl in the 30s. These were horrific droughts. And we see the bulk of those occurred early in the 20th century before we started adding CO2, before temperatures started ramping up. So again, this is just another indication that it's completely opposite of what we're being told. So we're being told that famine is one of the primary things that we need to fear about increasing CO2 and rising temperatures. Yet, again, we saw that an increase in 300 parts per million will lead to a 46% increase in crop growth. Part of this is due to the rising temperatures, means we've got an increase in growing season. There can be more plantings for more food. Killing frosts arrive or stop earlier in the spring and arrive later in the fall. Those things are benefiting crop growth and agriculture. We can look at all sorts of graphs comparing increasing food production and comparing that to CO2 and temperature. I'm not going to suggest that CO2 and temperature driving all these increases. That's ridiculous. There's mechanization and other processes, but it's certainly turbocharging crop growth by having this increase in CO2 and temperature. Interesting graph. I've talked with other people and they say, oh, well, that's because we're planting more acres. But yet, if we look at the worldwide acres planted, it's been relatively stable, maybe a little decline. So the acres have remained the same, but the grain harvested have increased significantly. And again, corn, we're tracing corn production versus CO2. Again, we see a great increase. So we're not seeing any negative impacts in the real world on food production. We'll take a look too. We're told that heat waves and increasing temperature will lead to increased mortality and death. But yet we had a spike this is the EPA Heatwave Index. We see that we had a spike in the 30s. Intense heat in the United States has actually been in decline since the 30s. These are the percent of stations greater than 100 degrees. Largest study known of its kind, 74 million temperature-related deaths were looked at in this study by Gasparini. They found that 20 times as many people die from cold-related deaths as they do from heat-related deaths. Again, it's completely opposite. I think we could state pretty categorically that global warming will save lives, and a lot of lives. Again, another study here from the UK, what they call excess winter mortality, seeing a significant decline, winter deaths as we go through, and again, related to probably increasing temperatures. And in the United States, we've seen that heat-related deaths have declined significantly over the last 50 or 60 years. We'll also look at extreme weather deaths. We're told categorically that deaths from extreme weather, climates, tornadoes, floods are increasing, and they're going to get worse. Just the opposite has occurred. We've seen since the 20s, there's been a 98% decline in extreme weather-related deaths, opposite of what we're being told. Granted, a lot of that has to do with better prediction, better forecasting. We can get ahead of some of these events to let people know they're coming. But what they're predicting to happen, we see that just the opposite is occurring. So significant decline in extreme weather-related deaths in the 20th century. This was a study done by the European Union. This study is a case example of how the pro-man-made warming people use and misuse data. We saw at the National Climate Assessment from concerning forest fires. In this case, the European looked at predictions of weather, temperature-related deaths going up to 2080. The headline in The Guardian was 160,000 more people to die in the next 60 years because of global warming. What they failed to report, the same study reported almost 260 deaths prevented by global warming from cold-related deaths not occurring. This is how it's reported. Again, it was the headline, 160,000 to die due to global warming. There are, I love this slide. This was from my latest video that I did on polar bears. We see here that polar bears over the last 60 years have been increasing. This is from Susan Crockford, increase in polar bear population. And this was from a study looking at bears in the high ice loss area compared to bears in a low ice loss area. And it turned out that bears along Russia and the Chukchi Sea, there was significant ice loss. Those bears, by every metric looked at, were much healthier, fatter. They had bigger litters, higher survival rates of the cubs. By every metric, the high ice loss bears gained weight and were fat and happy. The reason probably was they moved on land during the summer ice loss time, and there was just more food to eat. So this is an interesting study going exactly opposite of what the study had thought they were going to find. In fact, the PowerPoint for this slide, the last slide was, how do we message this to the public? In other words, they weren't worried about reporting the data. They wanted to make sure that they messaged the data correctly, because you wouldn't want to get information like this out that the simple bare necessities might not include ice. We'll take a look again at more severe storms. Tornadoes have been in a decline, but yet when we have those tornadoes like we did the other day, they usually link that somehow to climate change and global warming. Again, tornadoes in 2013 and 2016 had those were the two lowest number of tornadoes NOAA has ever measured going back to 1850. So tornadoes are not increasing, they're decreasing. And again, tornado deaths are in significant decline. Granted, the biggest thing here is prediction and storm shelters and the like, but a decline in the number sure doesn't hurt. We see hurricanes definitely not increasing, and the IPCC admits that there has been no statistical increase in hurricanes. We see, though, this is from Ryan Malley's information, that it sure looks like a slight decline in both tropical storms and hurricanes. And in the United States, NOAA, it's hard to get good long-term data on hurricanes because a lot of these hurricanes in the pre-satellite era could rise up and dissipate before they were recognized. So these are landfalling hurricanes. Any landfalling hurricane in the continental United States would be recognized and counted. And we see a statistically significant decline in the number of landfalling hurricanes. When Harvey made landfall a couple of years ago, we've been 12 years without a major hurricane making landfall in the United States. That was the longest period of that type since the 1860s. We'll take a look here at sea level, which is a warming planet, causes sea levels to rise. These are each of the IPCC climate assessment predictions going out to the year 2035. You can see with each subsequent prediction of sea level rise, it's decreased significantly from the outrageous 1990 prediction down to what they are today. They're still wrong, I think. I think they're estimating way too much sea level rise, but they're not as wrong as they were before. Again, we looked at sea level rise here, and again, we see that the rate of rise has been fairly constant. The key here is it's not accelerating. So now we'll end up, and I'm going to encourage you to sleep well. You're not destroying the planet. There's a lot of evidence that what we're seeing from rising temperatures and increasing CO2 are benefiting the Earth and humanity.
Well, thank you so much for, next week is spring break, so they're all ready to get the heck out of here. We appreciate your view on global warming and your insight, and your book is awesome also, so I appreciate your time today.
Thank you so much.
All right.
We'll do it next year.